It's been a few months since the last Starship launch, which lasted around 50 minutes before burning up during re-entry. Many of us thought SpaceX would take a long time before they would be ready for another Starship launch attempt. However, they always have the capacity to surprise us, and we are finally about a week away from the fourth launch, according to Musk himself. But as they are preparing for this launch, they faced an unexpected problem with the Raptor engine. This issue might affect their planned launch timeline, and we will talk about it in this video. Before we delve any deeper, please make sure to subscribe to our channel for future updates about the Starship and SpaceX's other groundbreaking achievements. On May 23rd, a Raptor engine exploded during testing at SpaceX's McGregor, Texas facility. This explosion was substantial, potentially causing significant damage to both the engine and the stand itself. SpaceX has not yet provided a detailed update on the cause of the explosion or the extent of the damage. The Raptor engines undergo a rigorous production and testing process. After being manufactured, they are tested at the McGregor facility. If they pass these tests, they are sent to Starbase for installation or returned to the factory to be held for future use. The engine involved in the recent explosion is believed to be a Raptor 3, as most existing prototypes are equipped with Raptor 2 engines. The Raptor engine family has evolved from the initial Raptor 1 to Raptor 2 and now to the more powerful Raptor 3. The Raptor 3 has shown remarkable performance, achieving record-breaking chamber pressures of 350 bar, which translates to 269 tons of thrust. This places it significantly ahead of its predecessors and competitors. SpaceX started working on these engines several years ago, with the first tests of Raptor 1 beginning in the mid-2010s. Raptor engines are designed to be full-flow staged combustion cycle engines, using cryogenic liquid methane and liquid oxygen as propellants. This design allows for higher efficiency and performance. From the start, SpaceX wanted to avoid relying on traditional aerospace suppliers like Russians. This led to the creation of the Merlin engines. These engines use a type of kerosene and liquid oxygen as fuel. They operate on a simpler and cheaper open-cycle gas generator system. Merlin engines are used in the Falcon 1, Falcon 9, and Falcon Heavy rockets. For example, the Falcon 9 uses 9 Merlin engines in its first stage and a modified version called Merlin Vacuum in its second stage. Over time, these engines have been improved, with the Merlin 1D being one of the most efficient rocket engines available. Despite the success of Merlin engines, SpaceX's goals for Mars colonization and deep space travel required a more advanced engine. This need led to the development of the Raptor engine. Raptor engines use methane and liquid oxygen as fuel, which is more efficient and can be made on Mars. These engines use a full-flow staged combustion cycle, which is more efficient and provides higher performance than the Merlin engines. This allows for higher pressures and better overall efficiency. The Raptor engine is designed to be versatile, meaning it can be used in both the Super Heavy booster and the Starship spacecraft. Currently, Raptor 2 engines are used in Starship prototypes and have been part of all 3 orbital launch tests. These engines have shown great performance and are key to SpaceX's missions. Like we already know, SpaceX has conducted 3 orbital test flights so far, 2 in 2023 and 1 in 2024. For the fourth launch, SpaceX will launch the Super Heavy Starship into orbit and attempt to land on a virtual tower. This means Starship and Super Heavy will perform a controlled landing in the ocean, hovering over a specific point until it runs out of fuel and falls down. This method has many advantages for SpaceX. The clearest evidence is their practice of landing the Falcon 9 rocket on a drone ship. It took several attempts before they were confident enough to do it on a real drone. So how will Musk and SpaceX execute this landing in the fourth launch? Why don't they land Starship on a drone ship but instead let it splash down in the water? Landing rockets is one of the most challenging aspects of rocket launches, and it's even more difficult when dealing with larger rockets like the Starship. The Falcon 9, for example, stands at 70 meters tall with a diameter of 3.7 meters and a mass of about 549 tons. It generates around 7.6 million newtons of thrust with its 9 Merlin engines. Landing the Falcon 9 was no small feat and took several attempts before SpaceX could reliably land it on a drone ship. Each landing required precise control and timing to ensure the rocket touched down gently without toppling over or crashing. Falcon Heavy, which is an even more powerful rocket, combines 3 Falcon 9 boosters, making the landing process even more complex. The Falcon Heavy stands at 70 meters tall and has a diameter of 3.7 meters. But its first stage consists of 3 boosters, each needing to land safely either on drone ships or back at the launch site. The combined thrust of Falcon Heavy's 27 Merlin engines is 22.8 million newtons, and managing this immense power during landing was a significant engineering challenge. Each booster had to perform precise maneuvers to ensure a safe return. Now, consider the Starship. This rocket, including its super heavy booster, stands at 120 meters tall, has a diameter of 9 meters, and a mass of about 5,000 tons. It generates a staggering 72 million newtons of thrust with its 33 Raptor engines, which is a colossal increase compared to the Falcon family rockets. The sheer size and power of Starship make landing exponentially more difficult. The Super Heavy booster alone is as tall as the entire Falcon Heavy rocket. The payload capacity of Starship also highlights its massive capabilities. While the Falcon 9 can carry up to 22,800 kilograms to low Earth orbit, Starship can carry up to 150,000 kilograms to low Earth orbit, and more than 21,000 kilograms to geostationary transfer orbit. This far surpasses the capabilities of Falcon Heavy, which can carry up to 63,800 kilograms to low Earth orbit when fully expended. However, with this increased capability comes increased complexity in landing such a massive structure. SpaceX is not just going to drop the rocket into the ocean, they are going to perform many tests before landing the rocket. One of these tests is the belly flop maneuver, where the spacecraft flips over and re-enters the Earth's atmosphere with its belly facing down. This maneuver allows for a controlled descent and landing similar to a skydiver. To simulate this maneuver, SpaceX will drop the Starship into the sea. The orbital landing test flights did not start with straight up and down trajectories like the first prototype test flights. Even those trajectories were much more difficult than the engines flying sideways at full orbital speed. To be safe on re-entry, you need to re-enter the atmosphere somewhere on the other side of the ocean. If something goes wrong, it'll cause problems for the experimental spacecraft. SpaceX has carefully considered landing the Super Heavy booster in the Gulf of Mexico. The rocket's flight path over the ocean ensures all debris will fall into the water if something goes wrong. The final splash point is a safe distance in the Indian Ocean, although this location is not under U.S. jurisdiction. This method is the best way to ensure human safety and increase Starship's success rate. The belly flop maneuver involves the spacecraft using its large surface area to create significant atmospheric drag, slowing down its descent without using much fuel. The Starship has a sprawling surface area of 545 square meters on its windward side, which acts as a brake during descent, reducing its terminal velocity significantly. During the belly flop maneuver, Starship's engines draw propellant from header tanks to avoid propellant settling on the belly side of the rocket due to atmospheric deceleration. This ensures the engines have a steady supply of fuel, even as the rocket falls belly first through the sky. Another reason SpaceX avoids catching Starship mid-air with Mechazilla is to protect the ground infrastructure. Starship is still experimental and needs more tests before attempting a mid-air capture. Any additional hardware around the launch pad could suffer significant damage if things go wrong. Some people might see the ground infrastructure as just a concrete slab, but it's much more than that. The launch infrastructure includes complex and expensive components such as the launch tower, fueling systems, and control centers. These facilities are vital for the safe and efficient operation of the rocket launches. We can see the significance of this from the first flight test when Musk said, "Anything that doesn't damage the launch tower is considered a success." This statement underscores the importance of the ground infrastructure in SpaceX's operations. The cost of the ground infrastructure can be immense. For example, building a launch pad can cost anywhere from $50 million to $200 million. The The risk of an unsuccessful mid-air capture could lead to catastrophic failures, potentially causing the rocket to veer off course and destroy the launch tower or other critical systems. Given the size and power of the Starship, any mishap could result in extensive damage. The Super Heavy booster, which is part of the Starship system, alone stands at 70 meters tall and generates 72 million newtons of thrust. And that's all for today's update. If you enjoyed watching and found it useful, please make sure to subscribe to our channel and hit the like button. Thanks for watching, and I'll see you in the next one.